Alright, so we're going to do some linear equation revision. Now the key word here is revision. So everything that I talk about in this fast video, I hope you've covered before. So I'm not teaching it so much as reminding. So a linear equation takes the form y equals mx plus c, and it's a relationship between x and y. It can be represented on this Cartesian plane, x-axis, y-axis. 1, 2, 3, so on, 1, 2, 3, 4, and so on. -1, -2, -3, -4, and -1, -2, -3, and so on. So, linear equation y equals mx plus c, and it can be represented on this Cartesian. Now, m in our equation y equals mx plus c will represent the gradient, how steep our line is. If it's a positive gradient, it'll look like this, and if it's a negative gradient, it'll look like this. The plus c is our y-intercept. That is, where will this straight line pass through our y-axis? Here's our y-axis. Where will the line pass through it? So, from y equals mx plus c, you know the steepness of the line, and you also know the y. So for example, y equals 2x plus 1. I know the gradient, the steepness of this line is 2, and I know that the y-intercept is positive 1. So a quick drawing of this, it passes through here. Y-intercept is equal to 1, and it has a gradient of 2. Now you should remember that the gradient is equal to rise over run. So that means that the gradient of this particular one is 2 over 1, which means that it rises 2 for every 1 that it goes across. So that point there must be 1, 3, because it's risen from 1 up to 3, and it's gone across from 0 to 1. Now, any line can be represented by 2 points and then joined together. There's y equals 2x plus 1, and there is a rough sketch of y equals 2x plus 1 passing through this point, 1, and this point, 1. Now again, if I was to sketch this, y equals negative 3x minus 2, the gradient is negative 3 and the y-intercept is negative 2. That means it's passing through the y-intercept at negative 2, y-intercept, and it has a gradient of negative 3. That means it's rising negative 3 for every 1 that it goes across. M equals negative 3 over 1. Okay, so if I'm starting at this point, I can start from any point, but this is the only point that I know at the moment. Down 3, 1, 2, 3, that brings me to negative 5. And across 1, make that 1 there. And I should be able to sketch this, y equals negative 3x minus 2, by joining up those two lines. What I've been doing here is sketching these linear equations using the gradient-intercept method. I know the intercept, I know the gradient, so I can sketch it using the gradient-intercept. I have sketched those lines using the gradient-intercept method. You should be able to do that. So that was the gradient-intercept method of sketching, given you know the function. But there is another method, the intercept method. Now, I only need 2 points on a graph to draw a straight line. So if I know the y-intercept and I know the x-intercept, then I can find out where that line is. So here's an equation, and I can sketch it using the intercept method. First of all, I can see, because it's in y equals mx plus c form, I can use the y-intercept, which I know is minus 5, as one of my intercepts. I also need to find the x-intercept. Now, if I want to find the x-intercept, you only have to remember, if you want to find the x-intercept, let y equal 0. If I let y equal 0, then 0 is equal to 2x minus 5. 5 is equal to 2x. X is equal to 5 on 2, which is 2.5. Now the reason letting y equal 0 finds the x-intercept is because that's literally what the x-intercept is. The x-intercept is the point at which y is equal to 0. Okay, so in this case, 2.5. 1, down to 2.5 here. Doesn't need to be to scale, I'm just sketching here. Now, that's it. I've used the intercept method to use the y-intercept, and then by letting y equal 0, finding the x-intercept, and then being able to draw that line. But what if it wasn't in y equals mx plus c? This is still a linear equation because there's no powers involved. It's an x and a y, it's a relationship between the two, but I can't use the plus c because it's not in the form y equals mx plus c. So if I want to find the y-intercept, find y-intercept, I need to let x equal 0 because that's exactly what a y-intercept is. Now if I let x equal 0 that means that 0 equals 3 times 0 plus 2y minus 5, which is 0. That's going to be 0, so I can just forget about it. 2y minus 5. That 5 can go over here. 5 over 2 equals y, which is 2.5. So the y-intercept in this case is 2.5. And then obviously for doing the same thing, if I want to find the x-intercept, I can let y equal 0. 0 equals 3x plus 2 times 0 minus 5. So 3x minus 5 equals 0. 5 equals 3x. 5 on 3 equals x, which is 1.66. Okay, so I've used my intercept method. Even if I don't have the gradient intercept form, I can still sketch this. As long as I know that to find the y-intercept, I can let x equal 0, and to find the x-intercept, I can let. But what if I had to do everything backwards? What if instead I've got a Cartesian plane and I've got a line that passes through these 2 points, negative 9, 3? Well, there's a few different ways that you can solve this, but I'm going to show you one. I know that all linear equations can be written as y equals mx plus c. Easy. I also know that the c value here is the y-intercept, and I've been told that. It's negative 9. So y equals mx minus 9. So I know that much so far. And I should also remember that gradient is equal to y2 minus y1 over x2 minus x1. Revision, you know this. Okay, so y2, we can pick our points here. Let's call this point y2 and this point y1. Let's call this point 2 and this point 1. Okay, so y2 minus y1. If this is point 2, the y value of point 2 is 0. The y value of point 1 is minus 9, so minus minus 9. The x value of point 2 is 3 minus, and the x value here is 0. I end up with 9 over 3. So the m value, the gradient of this, is 3. So that means that the equation of this line is y equals 3x minus 9. And you can do everything that you just did to go backwards and see if that's true or not. We can see that it has a gradient, 3 up, 1 across. We should be able to see that by doing rise over run. And you can also see that the y-intercept is negative. But what if someone made your life more difficult and didn't tell you the y-intercept? What if they just said, here's a line, there's a point on it, 2,5, and there's another point on it, 7,15? We can still tackle it the same way. You know that all equations take the form y, or can take the form y equals mx plus c. Now, we don't know our c value because we don't know what our y-intercept is, but we can find our gradient using y2 minus y1 over x2 minus x1. Now, assuming this is point 2 and assuming this is point 1, y2 minus y1 is 15 minus 5, y2, y1, over x2 minus x1, 7 over 2. That's going to be 15 minus 5, which is 10. 7 minus 2, which is 5. That's going to be 2. So now I know that y equals 2x plus c. I know the gradient, but I don't know the c value, and finding it's quite difficult. But, this pen's squeaky, but what I do know is that I have a y and an x, and it's a relationship. And that relationship has a gradient of 2, and it also passes through this point or this point. So I can sub one of those points in. Sub 715 into equation. Now if I do that, 15 equals 2 times 7 plus c. I know that 15 equals 14 plus c. I know that 15 minus 14 equals c, and c equals 1. So, therefore, y equals mx plus c, y equals 2x, that was our gradient which we found here, plus 1. Okay, that's been a flying journey through linear equations. That's 10 minutes on probably the things that you covered in half a term in year 10.